most people look at an airplane, they see a smooth metal body, long wings, and powerful engines hanging underneath. It looks clean, simple, almost effortless. But that calm exterior hides a machine that is far more complex than it appears. What you see on the outside is only a carefully designed shell. The real airplane lives underneath it. From the front, the airplane's shape looks almost alive, pointed and slightly curved. Designed not just to look aerodynamic, but to survive extreme forces. Behind that smooth nose cone is a tightly packed space filled with equipment most passengers never imagine. This is where the aircraft senses the world around it. Weather radar scans storms miles ahead. Antennas communicate constantly with satellites and ground control. Air data sensors measure speed, altitude, and pressure dozens of times every second. The airplane is always watching, listening, and calculating, long before a pilot ever reacts. As your eyes move along the outside of the aircraft, the fuselage appears like a simple tube. In reality, it is one of the strongest pressure vessels ever built. At cruising altitude, the air outside is so thin that a human could lose consciousness in seconds. Inside the cabin, everything feels normal because the fuselage is designed to hold pressure like a sealed container. The metal skin flexes slightly on every flight, expanding and contracting as the aircraft climbs and descends. Over thousands of flights, this repeated stress is carefully monitored, which is why aircraft structures are inspected down to the smallest crack. Inside the fuselage walls, hidden behind panels, insulation and wiring, is a maze of systems. Electrical cables run for miles through the aircraft, connecting sensors, computers, and controls. Hydraulic lines carry pressurized fluid that powers flight controls, brakes, and steering. Air conditioning ducts deliver cooled, filtered air to the cabin, often drawn directly from the engines themselves. None of this is visible to passengers, yet all of it must work perfectly, every time. Then there are the wings. From the outside, wings look thin and elegant, almost fragile. But inside, they are dense with structure. Massive beams called spars run through the wing, carrying enormous loads during flight. The wings bend upward as the airplane lifts off, sometimes flexing several feet. This bending isn't a flaw. It's a sign that the structure is absorbing stress exactly as designed. Inside the wings are fuel tanks, not separate containers but sealed sections of the wing itself. Fuel spreads across the wings to balance weight and keep the aircraft stable. Pumps move fuel between tanks constantly, adjusting balance as fuel burns. Even this process is automated, monitored by computers that ensure the airplane stays perfectly centered in the air. Along the trailing edge of the wing are surfaces that most people never notice until they move. Flaps extend during takeoff and landing, changing the wing shape to generate more lift at lower speeds. Slats on the front edge help smooth airflow during critical moments. Spoilers rise from the wing during landing, dumping lift and helping the airplane settle onto the runway. Each of these parts moves independently, often by small amounts, guided by sensors responding to speed, wind, and pilot input. Hanging beneath the wings are the engines, massive cylinders that look powerful from the outside, but are even more impressive within. Inside a jet engine, air is pulled in, compressed, mixed with fuel, and ignited. The explosion doesn't push the plane forward like a rocket. It creates a controlled stream of high-speed air that generates thrust. Surrounding the engine core is a large fan that moves enormous amounts of air around the engine, increasing efficiency and reducing noise. What most people don't realize is that engines are designed to fail safely. If something goes wrong, systems automatically shut down fuel, isolate damage, and protect the aircraft. Commercial airplanes are certified to fly long distances with a single engine, even over oceans. The second engine isn't just for speed, it's there for safety. Inside the cockpit, the airplane looks nothing like the quiet cabin behind it. Displays glow with information, showing speed, altitude, engine performance, and system health. But modern pilots are not manually controlling every movement. They give commands, and computers translate those commands into precise actions. When a pilot moves the control column, flight computers decide how much each control surface should move, preventing unsafe angles or excessive stress on the aircraft. Behind the cockpit, under the cabin floor, is another hidden world. Cargo compartments store luggage, supplies, and sometimes animals. These compartments are pressurized and temperature controlled. Fire detection systems constantly monitor them, and if smoke is detected, fire suppression systems activate automatically. Safety is laid, quiet, at the back of the airplane, tail may serve as a central fin. It plays a critical role in stability. The vertical stabilizer keeps the aircraft flying straight, resisting side forces from the wind. The horizontal stabilizers help balance the aircraft, preventing the nose from pitching too high or too low. Trim systems constantly adjust the surfaces to keep the aircraft stable without constant piloting or turning. There's the landing gear, preloaded from the front. When deployed, it transforms the aircraft from a flying machine into a gliding vehicle. Each green fan is built to absorb incoming forces, with shock absorbers filled with gas and fluid to cushion impact. Tires are filled with nitrogen to secure temperature and brakes use a porous material designed to withstand.
Gaps and breakers stabilizers stuck to the
What
plane.
ties all of this together is redundancy. No critical system exists alone. There are backup systems and backups for resilience. Multiple power sources, multiple computers, multiple communication points. Even if all systems fail at once, the aircraft is designed to remain controlled.
Great fiery seeds are gassed in the line.
Is why aviation has become so safe. Perhaps the most surprising thing is that the airplane never stops checking itself. Sensors monitor vibration, stress, temperature, and pressure across the entire structure. Data is recorded and reviewed continuously after flights, allowing problems to be fixed before they become dangerous. Safety